Hello. Now Bruno Nelta, who is a Senior Systems Engineer with Renesas Electronics, will introduce to us a new single-chip IOLink master device. Bruno, would you please start and introduce to us the major features of this new device?
Yes, the IOLink master solution is a second creation or innovation that we develop at Renesas Electronics. So our first creation was basically an IOLink device that we released with an integrated transceiver. And then we follow through with this approach of integration and brought to the market a new device on the master side, this time with a dual channel and transceiver. So if we look at this picture here, we can see that previously we were talking about sensor devices, but this sensor needs to communicate with the PLCs and remote IOs. So that's why we have to develop also a master device so we can close the loop and bring the IOLink information to the upper level on the network.
You were mentioning that this is a two-channel device you're going to introduce. Why did you choose that solution?
Yes, so it's this solution came after some investigation. So we decided to go with a 16-bit microcontroller with a dual channel transceiver. The reason being because there are many aspects in the industry, the way to look at this type of devices. So obviously, IOLink is a point-to-point communication, so you can only connect one slave to a master port. So the conventional way that you would find this type of application is having a very large Ethernet or field bus microcontroller that will drive several IOLink files. But then you go into the problem of having EMC and power dissipation issues. So another approach was to basically go to a more dedicated microcontroller, which may basically reduce the processing power on the field bus microcontroller. But again, this driven by a 4 IOLink PHY, which is still have an issue when it comes down to performance, EMC, and heat dissipation. So these two approaches were not sufficient for the ideas we had in mind, and then we went to a more scalable approach where we only provide two channels, but for the benefit of implementing IOLink masters with more than 4 IOLink channels. So after investigation, we came to the solution to implement a solution just between 4 and 1, which is 2 master to go ahead with this solution.
And what are the major features, what are the major highlights of the new product?
So the new product is also based on the 78K0R device family. So this is a very low power microcontroller from the Renesas Electronics portfolio with higher processing capabilities. This microcontroller can develop up to 25 MIPS at 20 megahertz, and this controller also can go up to 24 megahertz. So there are plenty of resources for developing IOLink master application on these devices. And not only that, we also have included into this device some data flash, which can be used for specific features of the new IOLink 1.1 specification, such as parameter storage. So this microcontroller enabled these new features within the single chip solution. We also have a CAN interface, a CAN controller available on this device for customers or users willing to develop CAN-based field buses. And we have additional IOs that can be used to drive LEDs or status, and also DMA channels. We got 4 DMA channels that can be used for dedicating the fault proof of the IOLink channel for each channel. And on the transceiver side, we have two fully independent IOLink channels with some integrated features such as over temperature, over current. There is also the possibility to save power by disabling one of the ports if one of the IOLink port is not connected to a sensor, for example. There is also the possibility to program the current drive for the driver for the transceiver, so that you can have an appropriate drive current for the sensor. So this transceiver also generates the wake-up pulse for the sensor, which is a requirement of the IOLink specification. So this transceiver and the IOLink microcontroller, all in all, is fully compliant to the 1.1 specification of the IOLink.
What about your tools for developing system solutions with the device?
In terms of tool, we develop a full platform for customers. So we don't just provide the silicon, but we like when we provide a solution to a user or customer, to provide a full solution where customers are not left alone with a piece of silicon and find out for themselves how to work with this device. So with our partner, Elmos, which help in designing the IOLink transceiver, and TMG, which are our partner for IOLink stack. We develop a specific protocol for communication and also make the scalability of the solution easier when it comes to putting more than 2 channels together on the IOLink master. So this tool works with our workbench, IAR workbench tool, so which is the general tool that we use for our microcontrollers. And also we starting to develop some starter kit that we will talk a little bit after. So in terms of the concept for the IOLink and the solution that we are bringing, really we develop, as I was saying, type of protocol which is called the SPI, some telegram SPI, which is a specific protocol developed for interfacing the IOLink master controller to the external host controller that will run the fieldbus, the fieldbus application, mainly industrial Ethernet application. So this can be done either on the V850 or RX or AirTech devices, which are other microcontrollers from our portfolio. But on the IOLink master side, the scalability is so effective via this telegram approach that we are able to develop application with 16-port devices and more than that if a customer would require to do so. Okay. So the protocol is optimized for synchronous transfer for communication, both cyclic and acyclic information, and also based on the configuration of the IOLink port. So there is a really configuration relationship between the host controller and the IOLink master taking place on this bus. So the way it works really is that you have a bus of information, and each IOLink master on the bus is able to extract the information that is related to its functionality. So this is a very simple interface via the SPI, so it only requires four pins to work with a host controller. Okay. Next, in terms of development tool, we have developed an emulator, as we do generally for our microcontrollers. So with this emulator, the customer is able to plug this emulator into this target system and simulate or emulate, if you want, the IOLink master controller. So this give him the opportunity to start his prototyping and also do some tracing and debugging work before implementing the design with the actual physical microcontroller. We also develop starter kits that a customer can use to as a trial for or evaluation for IOLink masterboard. So these boards are quite recent and also based on the try to make use of as much as possible of the features of the microcontrollers. So I can show you more in detail on this board. So this board comes basically with a header board that the customer uses to connect to a host PC. So this can be done via either a CAN interface or a USB interface. And there will be there is a TCI tool program that is running on the computer that is interacting with this header board. On the IOLink side, this is the IOLink master device with two IOLink channels based on the M12 connectors. So each channel has two LEDs that are used to mainly indicate communication, and if there are any errors on any of the channels of the IOLink, these LEDs will blink to indicate the problem to the user. Additionally, there is a second channel available on each port. So this second channel is configurable as input and output and a type 1 in relation to the IOLink specification. Furthermore, we have the possibility to set the bus address for the board. So if the customer wants to make a design with more than 2 IOLink channels, we have some add-on module that we are also providing. So these add-on modules are just similar as the module which is provided with the starter kit, but it comes pre-programmed, and then the customer can just plug the add-on module into the starter kit and already can implement 4 channels. So there is this design basically is design has been made to allow the stackability of 7 or 8 boards. So that gives in total a 16-channel IOLink master. So basically this to show how flexible this solution is and how scalable it is to work with this microcontroller.
Thank you very much.